Hello, viewers. In today's session, we are going to discuss yet another important and conceptual problem from domain of functions. Right. So here we have a new problem in which we are given a function f of x is equal to square root of sine inverse x divided by 2x minus 1, and we have to find out the domain of this function, right? So to find out the domain of this function, what we will do, we'll find out the domain of the function that is square root of sine inverse x, and the domain of this function that is in the denominator, which is 2x minus 1, and then we'll find out the intersection of these two domains to get the domain of f of x. So now let us consider first this function, that is square root of sine inverse x, right? Now the validity of this function, that is the square root of sine inverse x, the condition is that the expression which is inside this radical sign, this expression must be greater than or equal to 0, right? Because from simple algebra we know that if we have an expression that is square root of a, then a must be greater than or equal to 0 for square root of a to belong to the set of real numbers, right? So this a is either equal to 0, or it should be a positive real number. Then only square root of a can belong to the set of real numbers, because if we have a negative number inside this square root sign, then we'll get a complex number. So here we are dealing with only the real numbers. So square root of sine inverse x is valid only when sine inverse x is greater than or equal to 0. So now we have this important inequality, right? Now from here we have to proceed further to get the values of x which satisfies sine inverse x greater than or equal to 0. So for this we'll make use of some concept from inverse trigonometric functions. So from inverse trigonometric functions we know that sine inverse x, the range of sine inverse x belongs to this interval, that is from minus pi by 2 to pi by 2, right? So this is the principal value branch of sine inverse x, where this x belongs to this interval, that is from minus 1 to 1. So when sine inverse x belongs to this interval, we can generate an inequality, that is sine inverse x is greater than or equal to minus pi by 2, but it is less than pi by 2, right? Okay, now see here we have sine inverse x greater than or equal to 0. So what we will do, see sine inverse x, it belongs to this interval minus pi by 2 to pi by 2. Here we have 0, right? And we have also these 2 points. So sine inverse x is greater than or equal to 0. So it implies that we have to now take this interval only. That is sine inverse x is greater than or equal to 0, and it must be less than or equal to pi by 2, right? So we have to merge this part of the inequality with this one to get this inequality, that is sine inverse x is greater than 0, greater than or equal to 0, which is our this inequality, and sine inverse x must be less than or equal to pi by 2, which is our this inequality, right? So now we have to find the value of this x from this inequality. So now let us take the sine function of all these three expressions or the numbers, right? So we have sine of 0, then here we have sine of sine inverse x, and then here we have sine of pi by 2, right? So sine 0 is simply 0, and here this sign and this sign it get cancelled, so we have x, and here we have sine pi by 2 which is equal to 1, right? So now we have obtained this inequality, that is x is greater than or equal to 0 but it is less than or equal to 1. So now we have obtained the domain of square root of sine inverse x as x belonging to this interval, that is 0 to 1. And remember, here we have the equality, so these 2 points are included, right? So now let us consider this function which appears in the denominator. So here we have 2x minus 1, right? Now since this expression 2x minus 1 it appears in the denominator, so this function should not be equal to 0, because the moment this uh, expression it takes the value x is equal to half, this expression 2x minus 1 it becomes 0, right? So the expression 2x minus 1 is valid for all real numbers except x is equal to half. So the domain of 2x minus 1 which is in the denominator, the domain is all real numbers except this value, that is half, right? So now we have the two domains. This domain can be represented by d1 and this domain can be represented by d2. So now we can find out the domain of this function f of x. So let us take the domain of f of x as d. So d is the intersection of d1 and d2. So by intersection, we mean that we have to identify only the common values of x satisfying both these functions simultaneously. So now let us represent these two domains on the real number lines. So here we have minus infinity, here we have plus infinity, right? So here we can write 0 and here we have 1. So x belonging to this interval, that is 0 to 1, it may be expressed or it may be represented like this. So here we have this region, that is from 0 to 1, and remember these 2 points are also included in the domain of the function square root of sine inverse x, right? Okay, so now let us represent this domain d2. So d2 is r minus half. So here we can take this number, that is 1 over 2, that is half. So this domain d2 it goes from minus infinity to half, and remember this half is not included, so we'll make a circle over here and we'll exclude half, and then we go from half to the entire this positive real number line, right? So here we have from minus infinity to half, and then we have union, and then we have half to plus infinity, right? So this is d2, and here we have d1. D1 is the interval 0 to 1, so this is d1. So now the common region is from 0 to half, that is from we can write 0 to half, and here half is not included. And then we have the union, and from here we have half to 1, right? So here we have half to 1, and 1 is included, here half is excluded, right? So this domain D is given by the union of these two intervals, that is 0 closed, half open, union half open, 1 closed. So if we look at this real number line, then we can see that the region from here to here is not included in the domain of D1. So we'll exclude this region, and then from this point, that is 1 to infinity, here 1 is included, but the region that is from 1 to infinity is not included, right? So the common region is from 0 to half, and 0 is included because here we have 0 included, and then 0 to half, and then half to 1, and 1 is also included. So the domain is given by this expression.